I wanted to go ahead and give you a quick review of the material that was covered in Chapter 2. That way you can spend this week reviewing the different topics and making sure that you're really knowledgeable in all the different things that we did in the chapter. We started by looking at some graphs, some graphical displays of data, and I looked at the graphs based on the type of data that you're working with. There were some graphs that we used for qualitative data and other graphs that we used for quantitative data. We looked at pie charts and bar graphs for the qualitative data, and we looked at histograms, which are bar graphs, and stem and leaf displays for the quantitative. So make sure that you understand how to read each of those different graphical displays. So that was the graphs. Then we started taking a look at numerical descriptions of data, and we started with measures of center, the mean, the median, and the mode. Which measures best often depends on the shape of the distribution. If you have skewed data, we like the median. If you have symmetric distributions, we tend to say that the mean is considered the best measure of center. Measures of spread, there were three of those as well. There was the variance, the standard deviation, and the range. Which measures best there is a really easy question, because which measures best can be described just as the standard deviation. That's our favorite, and we need different ways of interpreting the standard deviation. Throughout the course of Chapter 2, I've given you three. Chebyshev and the empirical rule were given at the same time, and then I believe I came back and gave you the modified empirical rule at a later time. Chebyshev's theorem is useful because it works for any set of data. The empirical rule, better numbers, but it only works for mound-shaped symmetric distributions. The modified empirical rule is kind of the one, the in-between one, that works, the numbers are better, and it works for skewed distributions. Typically in business, we either see symmetric or skewed distributions, and so we're either using the empirical or the modified empirical rule. The main reason I gave you the modified empirical rule is because I'm expecting on your projects for you to run into some skewed data, and I would prefer you to work with the modified empirical rule than with Chebyshev. How we use the rules, there's a couple different ways we can use them, but the main thing I want to get across to you is that we interpret the standard deviation using these rules. And if you have the empirical or the modified empirical rule, we use the mean plus or minus 2 standard deviations. That's a lousy 2, but you get the idea. We expect most data to fall within 2 standard deviations. If we're forced to use Chebyshev, then the numbers are smaller, and we have to bump it out to 3 standard deviations. And so when I tell you or ask you to interpret a standard deviation, I want you to use that to tell me where you expect most of the data to fall. And we'll use whichever rule applies, we'll use the corresponding interval of values. We also looked at measures of relative standing. There were 2 measures of relative standing that you need to be aware of. Percentiles is the one that is pretty common, so make sure you go back and review percentiles. It talks about the percentage of the observations below a point, but we're going to be looking more at z-scores. Z-scores are things we're going to use here in Chapter 2 for outliers in a second. They're also going to be things that move forward as we look at the normal distribution a little bit later in the semester. And that's the last topic, was defining what outliers are. Again, this topic defines outliers based upon which rule we're looking at. If you're working with Chebyshev, values that fall more than 3 standard deviations away from the mean are considered outliers. If you're working with the empirical or the modified empirical, outside of 2 standard deviations. And then the last topic we looked at was 2 different methods for detecting outliers. The way I've been mentioning in this video, in this review video, we've been talking about 2 standard deviations and 3 standard deviations, and that really goes hand in hand with what we call the z-score method for identifying outliers. The other method for defining outliers, or finding them, detecting them I guess is a better word, is the box plot method. And so excuse me, those are all the different topics that we've covered in Chapter 2. Hopefully that all made sense to you. As I was going through there, you started wondering about one of those topics, or you weren't quite sure what I was talking about, I'm going to encourage you to go back in the text, in your notes, take a look at some homework problems and review those. Several of these topics are going to be covered on your first project, and most of them will be covered on your first exam. So take this week and make sure you are reviewed in Chapter 2 and you're ready to move forward the next time we get together. So long.